Well, hello everyone, and welcome to 8.1. This is the sine law. So the first thing we're going to go over is we're going to go over how to label a triangle. And so first I'm going to label this triangle as A, B, C. And so if we're talking about this angle would be capital C. This angle would be capital A. And so we use capital letters for angles. Now for the lowercase, if we're going to talk about side lengths, if we say that this is A, capital A for the angle, if we go to the opposite side, we must label this as lowercase a. And likewise for the rest of them. So this would be lowercase c and lowercase b. So when we talk in 8.1 and 8.2 about labeling our triangle, no matter what the letters, the capital letters are the angles and the opposite sides are the lowercase, which represent the side length. So when do we use the sine law? We typically use the sine law in acute triangles, and what that means is they're triangles that do not have a right angle. So the sine law, which is this video, the next one, which is cosine law, we use these laws when we're using acute or non-right angle triangles. The different cases that we can use the sine law, so there's going to be, again, sine law versus cosine law, and you're going to have to be able to recognize when to use each. So the cases that you would use sine law is when you are given any two side lengths with one of the angles, but that one angle that's given must be opposite the two side lengths. So for example, if this is a triangle, if you were given this side length and this side length, you would have had to have been given this one angle, for example, because it's opposite, or you could have been given this angle because it was opposite. The other case is you'd be given two angles and one side length, and so what that would look like, that would be any two angles, so for example this one and this one, with a side length. So in this case, even though you're given these two angles, it's always possible to find the third. If you remember, the sum of the interior angles adds up to 180. So the biggest thing with sine law is that you always need an angle and an opposite side length to be able to use the sine law. Here's the formula that you need to know for sine law. This we would typically use if you're looking for a side length, and this we would use typically with if you're solving for an angle. Now, either or will work in any situation, so it does not matter if you pick the right or the wrong one, you will still be able to solve it. And we'll do an example later where you can see how we have two equal signs, which we usually don't write two equal signs, but in a situation, if we have enough information, we can, for example, ignore this one and only work with this one, just like we did with our similar triangles. Likewise over here. So you'll need to memorize these formulas. And so now we'll try the first example. So I'm going to label this as A, B, C, just so that we use the same letters as before. And so if we go across, this would be lowercase b, lowercase a, and lowercase c. So if we write out and we look at our question, we're asked for how far apart the two locks are. So we're looking for lowercase b. So if we are looking for a side length, we're going to do A over sine A, B over sine B, and C over sine C. And now let's substitute some values in. So we know what big B is. It's 52. We don't know what little b is, but we know we're looking for that. And it's over sine 52 because we knew what the big B was. If we look at C, we don't know what this angle is for big C, but we do know that its side length is 2.5. And if we look at A, we know that we don't have a side length for A, but we do have the angle. Now, this is the case where you're given two angles and a side length. It is possible to find this. How is that? We do 180 minus the 66 degrees minus the 52 degrees, and we end up with 62 degrees. So actually, we know that angle C is 62 degrees. So we can fill that in. So now that we look at this, we are trying to solve for B. So we have three different parts that we could use. We know we're going to use this one here because we have both parts. And we know we have to use this one because we're looking for B. So when you look at the two that you're going to use, we're going to set this up here and we're going to ignore the A. So if we set this up and we start solving, if we're solving for B, we need to move this divided by sine 52 to the other side, which then gives us B equals 2.5 times sine 52 degrees divided by the sine 62 degrees that's already there. And if you type this into your calculator, you will get approximately 2.2, and our units were kilometers. And so there you go. At the end, you should be writing your therefore. Therefore, the two locks are 2.2 kilometers away from each other. So if you have any questions about that, make sure you write that down. The next example is the different case where you were already given the angle and the side lengths opposite each other. So if we write our sine law, we're going to have, and again, what are we looking for? We're looking for V, which is this angle here. Because we're looking for V, we're going to start off by having the signs on top. So notice these are just the flips of each other in the formula here. These are just the opposites of each other. So we have sine V over little v, we have sine t over little t, and we have sine u over little u. And if we label over here, this would be little u, this would be little t, and this would be little v. And so subbing in, we have sine v over, we know what little v is, it's 11.1. And we have sine big T, which we know is 31, over little t, which we know is 5.8. And we have sine u, and we know nothing about the u's. So this one's pretty easy to tell which of the two we're going to use. That would be these ones, because we are looking for the v. And in this case, we don't know anything about any of these values, but we know everything here. So if we set this up, we're going to bring this divided by 11.11 over. So we have sine v equals 11.11 times the sine 31. So we just brought that over, and it's still divided by the 5.8. And then if you're trying to get v by itself, so you have to take sine to the other side, and the opposite of sine is sine inverse. So we must do sine inverse of everything that's over here, and divided by 5.8. And if you type all of that into your calculator, you would get 80.3, and to the nearest degree is 80. So remember what we said about being accurate. It's best to keep that as is, because if you take a decimal, it will not be as accurate. And finally, you should have your therefore statement. If you have any questions, make sure you write them down and bring them to class. Great job.